Hello everyone, we are here to present our submission of the Mechanism Sessional Tutorial 5. The team members are Indrajit Chaudhuri, Ankit Dhaka, and myself Aditya Madhukar. We have attempted question number 3, which is related to dumper trucks. Let us look at the problem statement. So, dumper trucks typically have a gravity driven rear opening which has to be manually unlocked when it dumps. An idea to have a mechanized door that opens as the pin tilts is shown in the following figures. Synthesize and make a simulator for the mechanism, taking into account the functional relation between the angle of opening and bin tilt angle. Here are the diagrams that were given to us for reference. Let us now move on to the mechanism. Earlier in tutorial 4, we had solved a question about a dumper truck mechanism using the overlay technique to find the correct position of the joints relative to each other. However, that was a simple 4-bar mechanism as shown here. The current dumper truck model that we are attempting, however, is more sophisticated. There is now a rear door that opens as the cargo hold is tilted. This door helps to keep the cargo secured properly. The angle of opening is also more than regular dumper trucks that use only gravity to keep their bin doors open for the same extension or tilt of the dumper bin. This mechanism can be drawn in a simplified manner as shown in the following figure.
Hello everyone, my name is Ankit. This is a kinetic diagram of our dumper truck mechanism. This representation is a 6-bar mechanism which has 1 degree of freedom. There are 6 revolved joints, 1 prismatic joint which is motorized to allow the beam to tilt. As we can see, O1A contains a piston which is the motorized part of the beam. It is used to vary the length of O1A. Depends on how much the point A is raised or lowered with respect to the truck. The beam door opens to a certain extent. Here the beam door is represented by CR. As shown, the actual door is always located at right angle to CR. And it is just a structure, so it is not part of the mechanism. This is a systematic diagram showing the measure angle calculation. L1, L2, L3 and L4 are the links of as shown. This graph shows the variation of the beam tilt angle with the beam door angle of our model. The x-axis is the angle θ1, which represents the beam's tilt angle. The blue line is an angle θ2, which represents the angle between the door and the horizontal ground. The red line is the angle by which the door opens relative to the beam itself. As we can see, it increases as the beam is tilted more. This ranges from 0 degree to around 70 degree, which is the maximum span of our design. Before going further, let us just look into two important concepts. First is the Griswold's criteria. It states that in a 4-bar mechanism, the shortest link will act as crank. That is, it will rotate completely only if this condition is satisfied. L plus S smaller than equal to P plus Q, where L represents the longest link, S represents the shortest link, and P and Q represents the other two links. Second is the dead center configuration. This is an extreme configuration of mechanism where there is uncertainty regarding the direction of further motion. It is obtained when two of the links become collinear. At this configuration, the mechanism may move in more than one direction.
Hello, I am Indrajit Chaudhuri and I will now be talking about the model synthesis process. So this is what the assembly of the model looks like on SolidWorks. Here on the left, we can see the menu with all the separate parts listed. All these individual parts like the base, the dumper bin, links and the truck body have been made primarily through sketches. For example, this front portion has been made from this sketch of a rectangle which we extruded to form this cuboid. After that, we used chamfer to remove portions from the top and back that were unnecessary or interfered with the working of the model, resulting in this final shape. These links were also made by extruding 2D sketches. This piston, which forms the prismatic joint, was made through the revolve tool as it is axis symmetric. We sketched the cross sections and then revolved those to form the hollow cylinder and its solid extension. We started from the base, which is again just an extruded rectangle of length 0.3 units. This enabled us to fix up the 3 ground links. Since we are using SolidWorks, we did not have to get the individual measurements manually. This link was set to be 0.15 units in length, this link was set to be 0.02 units, and the piston cylinder is 0.12 units in length. Here it wasn't too difficult to obtain the other measurements since we can clearly see everything in the assembly itself as we keep on adding the components one after another. This piston here is the mechanized part of the whole model. A motor is used to extend this prismatic joint in order to raise the bin. As it is raised, the back door opens outward. Two angles are of special interest, the bin tilt angle and the door opening angle. We have recorded these two values and plotted the graph that was shown earlier. This angle θ1 represents the tilt and this angle θ2 between the horizontal and the door is an indication of the opening angle. Their difference gives us the angle by which the door opens respective to the truck. In the fully closed position, both these angles are 90 degrees. In the maximum open position, θ1 is around 114 degrees while θ2 is 42 degrees, thus resulting in an opening of around 72 degrees. This is much more than what would have been possible with the same piston extension had the truck relied solely on gravity to keep the door open. An interesting observation is that it is possible for these 4 links to satisfy the Grashof criterion. However, that would result in an unwanted motion beyond the desired range of the door, as this smallest link would then become a crank. To avoid this, a constraint has been set on its range of motion, which limits this link from getting inverted beyond the maximum range. The extreme position is thus almost a dead center configuration, where these links become collinear with an uncertainty regarding the direction of further motion. Here is a simulation video showing the piston extending to 80% of its full range in order to remain within a safe range, and then closing back again. It is also possible to add locks to the bin door to secure the cargo, but this design is such that a lock is not absolutely necessary. This is because unless we use a motor to extend the piston, gravity keeps it in the down position by default. The links are so arranged that the only way to open the door is by extending the prismatic joint, and so the cargo gets secured automatically. So that is it from our side. We had a great learning experience through this project. Thank you very much for watching.